This is a article that just appeared in Nature that looks at whether flash floods are now more often devastating the world's driest regions. In terms of climate change, we know extreme events of rainfalls have increased. There is also arguments that deserts are expanding. There is, of course, urbanization happening. And all these things together can make conditions become more and more favorable for flash floods. What are flash floods? Usually, very intuitively speaking, it's a flood that occurs very rapidly, right? But the US agencies have a definition that says the flood occurs within 6 hours or less after the rainfall event, then it's a flash flood event. So the amount of rainfall may depend on what kind of land use you are dealing with. So drier regions produce flash floods even with a smaller amount of rain, as little as 10 millimeter per hour, because the soil is too dry and it doesn't soak the water as fast as actually a wet soil. So all these things come together, and people are also moving more and more into urban regions. So if you have urbanization happening, you already pave the regions too much, then you increase the runoff anyways. Plus, if you expand into drier regions, then you are exacerbating the situation. And then there are some chronically vulnerable countries now in terms of where such events are occurring. Pakistan and some parts of Middle East are a good example. Here is a picture of a family navigating floodwaters to reach a village in Meher, Pakistan after heavy rains in August 2022. If you remember last year, pretty much the entire country was underwater because of the heavy rains, and there are related papers arguing why this is happening more and more in northwest India into Pakistan, because the Arabian Sea is warming, which itself may be related to the Middle East warming. It's a desert region which is warming much faster than the rest of the land regions, for example. So the paper uses this kind of a Köppen climate classification map to look at where the flash floods are increasing. These are the major climatic types based on patterns of average precipitation, average temperature, and natural vegetation. This map depicts the world's distribution of climate types based on the classification originally invented by Vladimir Köppen in 1900, so all the way back. And the map looks like something like this, and you can see the desert region here, you can see the dry and wet regions here, you can see the drier regions here, the wet rainforest regions, and so on. You can imagine that the runoff and the amount of flooding will depend on the amount of rain, but also whether there is a lot of vegetation and soil is able to soak the water that's falling, etc. Right? So keeping that in mind, this is the collapsed portion of a railway bridge over the Chakki River after the flash flood triggered by heavy monsoon rains in Dharamshala Saturday, August 2022. So related to the Pakistan floods as well. And this is in the northwestern India, in the foothills of the Himalayas, where actually Dalai Lama often comes to live. That's the Tibetan refugee place. And that's looks like a river with lots of mud flowing, which wiped out the bridge. And here you can see another terrain from the Bureau of Land Management from the US, which is showing basically very dry, maybe it looks almost like a dried riverbed where some flooding has happened. And oftentimes in the US the problem is people try to drive through these floods without knowing how dangerous or how deep they are, how fast the water is flowing, how much water is flowing, and so on. Looking at some numbers, dryland flash flood risks. The number and intensity of flash floods in arid and semi-arid areas are rising as climate warms. Swelling cities and populations are also putting more people at risk, as I just said. So looking at heavier rains in a warming climate, the intensity of deluges is creeping up because warmer air holds more moisture. Think of a sponge that you are putting more and more water into, and precipitation happens when you have instability. So if you press the sponge at one point, it's not going to drizzle, it's going to pour at a point. when it's saturated with water. So that's kind of what we are doing with extreme events. Looking here at 5-day maximum rainfall in dry lands in millimeters. So it's accumulated 5-day rainfall. In the 1980s, we were at an average of 100 millimeters. So in 2010s, we had reached 108. Relatively little rain can trigger flash floods in parched soils. So if you're increasing rain and rain rates, then you create these conditions for flash floods. More flash floods, so the rate of sudden inundation has escalated in recent decades. Number of fatal floods in dry lands, you can see from the 80s, 90s, 2000s to 2010s, it has jumped quite a bit, gone from close to 10 or so to nearly 40 by 1980s to 1990s, and jumped to over 100 by 2000s and 2010s. In the 2010s it jumped to over 120 or so. Okay, so clearly there is a trend, and there is of course a confounding of urbanization, deforestation, conversion to agricultural land, etc. also matter here. Okay, and it turns out that flash floods kill many more people. So fraction wise, if you look at river floods versus flash floods, the flash floods are under 50%, but the mortalities from them are majority of the deaths resulting from flash floods. More people, so populations are rising in drylands as well, from 40% of the global total in 2000 to 44% by 2020. So people living in drylands in billions has gone from a couple of billions, just over 2 billions in the 1990s, to now close to 3.5 billion by 2020. So that's a jump of 4%. Okay. Bigger cities, urban expansion is rapid in dry areas, notably in the Middle East, India and China. So you can see Evanai's dryland area in 10 to the 4 square kilometers has increased monotonically, and it may be even be accelerating in the 2010s compared to the decades before. This is vehicles crossing a bridge over Yolo bypass in Sacramento, California, where weirs divert floodwaters away from houses onto floodplains. So we'll see in a minute what are the steps needed to be taken to deal with these menace of flash floods and the potential for them to increase with global warming, especially in dry regions, with dry regions themselves expanding with global warming as well. Global flash flood disasters. Flash floods in drylands kill more people than do those in wetter areas, because dry soils repel water and local populations tend to be unprepared. Okay, so they don't expect floods in their region. Since 2000, drylands have experienced 47% of the deadly flash floods, yet 74% of related deaths, which is what I just mentioned. So here we are looking at bluish colors as wet regions, and the yellowish orangish colors are the dry regions. We are looking at 1995 to 2022, and previous periods 1966 to 1994 and 1938 to 1965, with data coming from various sources including documented evidences. Deaths, here the circles correspond to 1 to 99, 100 to 999, or 1000 plus. So larger the circle, larger the number of deaths. Almost 1/3 of Pakistan's population lives in areas prone to flash floods. So you can see that if you look at the trends from 1938 to 1965 to darker colors, there are increasing numbers and increasing flash floods as well over these regions. US is small in terms of mortality for various reasons of why vulnerability is low, whereas if you look at the global south in here in Pakistan, Afghanistan, India and so on, the number of deaths can be very high, and it has increased from 1938 to the present, of course, because there are more people exposed, population is higher. Africa is all over the place with its wet and dry land flash floods, and so is Europe. So nobody is really completely immune to this. Everybody faces the risk, but global south has much more risk. So what are the various steps? Gather data and map risks. So risk maps that are constantly updated based on census data, population densities, infrastructure, availability of early warning systems and so on are very critical. Gathering data especially is important, even including things like digital elevation maps, which are needed to make accurate flood forecasts, for example. Develop early warning systems, so that relates directly to the early warning systems. So for a country like India, the weather forecast short and medium term, so 1 to 3 days, 3 to 10 days extended range from weeks 2 to 4, and seasonal forecasts have gotten much better in the last 10-15 years. And there is this framework under the subseasonal to seasonal forecast project under the WCRP, World Meteorological Organization, that has ready, set, go kind of steps where you use longer term, let's say seasonal forecasts of a monsoon to prepare the system for dealing with flash floods or other weather related disasters. Then ready, set is where you use extended range week 2 to 4 forecast to put people, disaster managers in place, equipment in place, preparing centers to protect people or hydration in terms of heat waves and so on. And the go step is days 1 to 10, where you know that something is imminent, so then you put everything into action and be ready to respond instantly, right? So boost resilience to sudden floods. So this includes various things like natural climate solutions, so deforestation, and even urban areas can have permeable pavements, dryland swales, and ways to manage runoff from rains, etc. And there is some literature arguing that sometimes hard structures that give people or try to give people protection against floods and flash floods can lead to a maladaptation and can increase vulnerabilities in some circumstances that you can look up. So one has to be careful. But levees, dams, etc. have all been used, especially by China, which is very proactive on these things. Plan for long-term resettlements. There have been examples of smaller resettlements, but China has had resettlements of, I think, order 500,000 or more. Of course, China can do it because it's not a system where people are asked whether they like to move or not. But there are many psychological issues and other issues that have to be dealt with, and we'll see that in a minute from another paper. Provide finance beyond disaster aid. So it's not just about funds to recover from disaster for food and shelter, but also about insurance for flood damage and government role, the insurance company's role, and so on, all begin to play a role. So that has to take beyond just managing the recovery from disaster, but preparing for longer term resilience as well. Improve public awareness and responses. So this includes some social science, some psychology as well, in terms of behavioral responses needed, and we'll see a map of that, and how people perceive, for example, flash floods versus river floods. There is literature showing perceptions are very different, experiences and the post event response and memories also change. People remember events as they happen. If it doesn't happen for a few years, they tend to forget. So you have to be always careful of those things as well in terms of eliciting response again next time. Okay, so this is from a paper which looks at key characteristics of each quadrant in the managed retreat conceptual model. Incredibly difficult to imagine moving people at a large scale, especially when developers say they can provide enough resilience to the buildings, infrastructure, etc. Nonetheless, it's becoming more and more obvious that we have to have plans for managed retreat in many cases. So here we are looking at only residents, the axes go from residents do not initiate the move to residents initiate the move, and in this axis only residents benefit from relocation and broader society benefits from relocation. So then you will look at things like greater good, mutual agreement, self-reliance, and being hunkered down. So depends on how people do it, depends on, especially in a country like the US, it depends on whether you are in Texas or California, because people's perceptions on what their rights are and what they will do in response to climate or even government information on what needs to happen can be very different. A greater good include things like residents feel risk is tolerable, benefits accrue to broader society. In this case, societal benefit cost ratio justifies relocation when you do greater good displacement, and moderate likelihood of occurring can also be a reason. Okay, so this is in terms of the various sectors we are looking at. Mutual agreement, residents feel risk is intolerable. Being hunkered down, residents feel again risk is tolerable. Benefits accrue to the residents, if anyone. So you can see the numbers are very different here. It's not the greater good. Political will to implement retreat is low, so you can see this is larger here in stature than here. Societal benefit cost ratio does not justify relocation. So how you think about what is equitable, just, and societal benefit and the investment you would make based on your beliefs can change as well. Under self-reliance, residents feel risk is intolerable, but benefits accrue to the residents again. Numbers are smaller here in these cases as well. Political will to implement retreat is also low. Societal benefit cost ratio does not justify relocation, and moderate likelihood of occurring. Okay, so you can read up the paper if you want more details. I just wanted to flash the figures to see that people are thinking about flood disasters and how to deal with it, not only from early warning systems, improving forecasts and their transmission to people, last mile issues of how people will use the information, etc., but also longer term strategies in terms of adaptation of moving people. This is another one looking at extended risk assessment framework, including behavioral factors and disaster risk reduction. So since people are involved in the response and in action in response to early warnings and other kind of disaster risk management issues, you need to include people as well. So here we are looking at disaster risk reduction. So stakeholders can be government, business, and households which talk to each other to make the system better, with goals being protection, spatial planning, forecasting and evacuation, insurance and risk mapping for businesses, flood proofing, so buying insurance and deciding whether to buy a property in the flood zone is for household level decisions, which gets feedback from this sector here, examples of factors influencing behavior and perception in disaster risk reduction, and here feeds to influence risk or risk components. Okay, so risk assessment is involved here. So examples of factors influencing behavior and perception in disaster risk reduction: economic, such as income and equity; social, such as age and literacy rate. So these go into what can be considered as vulnerabilities. So risk in the IPCC framework is multiplier of hazard, like flood, versus multiplied by vulnerability, multiplied by exposure. In AR6 they have also added response, so this includes response as well. So geographic, so scale and distance to the flood zone as defined by, let's say, a government agency. Culture, such as heritage and language, can matter, and information, media, and data availability. So that gets feedback from risk information or flood events. And risk assessment includes hazard, events and flood extent, depth, and so on. Exposure, so people and assets. Vulnerability, so damage function, which is used typically in integrated assessment type models. All of them together determine the risk, which is the expected annual damage in this particular paper. So they have a kind of a schematic way of thinking about it, risk versus time. So you have increasing climate change and exposure increasing your risk, and then you have rational behavior and disaster risk reduction measures bringing your risk down. And in this case, in the risk perception may happen after the first event, so risk is underestimated, and then the event brings action, and then you again begin to drift back away from where disaster risk reduction and rational behavior should allow you to be in terms of risk being lower. And if you have different events, so two events, what happens, so you may come closer to actual reality, what is needed, and with rational behavior and disaster risk reduction measures. And if you have multiple events, then you know how it happens. So this is how human mind works. There are examples: the 2003 floods in England, the damages were large. People were told afterwards that it was the probability of the event was increased by climate change, so the people were able to take some actions like reducing their energy use and so on. But after a few years, nothing happened in terms of another flood, so people had just forgotten about all those good measures to reduce their impact on climate change. So this is the way human beings work, so we have to keep those in mind when we build disaster risk reduction, in this case for flash floods, but this works for all disasters as well. Okay, so I'll leave it here.